Okay, so we're going to do basic raycasting at first, and then work into some more advanced Python using a little bit of vector math. So first things first, I'm going to make a mouse aimer, which this is logic. So this, we add a logic panel, and a mouse sensor, and turn it to movement. And we add a mouse look, and we turn off the y-axis. So now when I hit P and move the mouse, this should spin in place, and it does. So I'm going to duplicate that. And then turn this off and turn this on, and then parent this. So now we got kind of a gimbal thing. Turn the sensitivity down, so it's a little easier to work with. All right, now we've got an aimable platform thing. You could use this for first-person shooters, all that kind of stuff. But we're not using that for that today. So this will be your hitbox. So I might as well put the code in there, because it's going to have to get pushed around anyway. So we'll do Python, mouse, and then left click. And then we add a Python text editor, or whatever code language you're editing, text editor. So left mouse. Why don't we just do L mouse? That sounds better. All right. So to build a raycast, you need an endpoint. So, oh, I just thought I'm going to cast from this, not from this. So since this is parented to this, we'll add a property to it and call it head. And then if head ob not in own. So if we don't have the property head object, for child in own children, if head in child own head ob equals child. So this only has to run once, and then it snags that. And then after that, own head dot world orientation. Thought something looked wrong. So own head dot world orientation column 1 is the y-axis of this object. If I flip this to 0, that's this axis of this object. If you flip it to 2, that's this axis. So 1, 2, and 3. So we're going to say 1 because we're going to raycast out this axis. And then we need a distance. So let's say like 10 units. All right, but so that's just a vector from 0. It's not from any point in space. So we need to do own head dot world position plus, and then put a parenthesis around there. So now wherever you move, you'll be casting 10 points ahead of his head, no matter where it is in the map. So start equals own head dot world position, and we're going to turn head to no collision just for now, and then past, this is the distance that will be cast past the ray. So next after past is property. This is the property it'll be looking for. We'll just leave it blank for now. And then next is normal. This is a switch to modify the behavior of the normals, and I usually set it to 0. And then next is X-ray. I set that to 0. And then next is polyproxy, and I set that to 0. This was for dealing with triangle meshes and trying to get faces to manipulate, so you don't need that at all in this one. So ray equals own.raycast and start past norm X-ray poly. So what this really does is this ray becomes a list, and ray 0 is the hit object that's hit. And if there's not a ray 0, that means you didn't hit anything. So we can do if ray 0. Now that means that the ray hit something. We could say print I detected, and then space, and then plus ray 0 dot name. So this is just to kind of prove that it's working. And we want to see the ray, so we do bge dot, actually, bge dot render dot draw line. So ray 1 is the hit point of the ray, and start is where we're going to be drawing the line to, and we'll have it so the line is white. So now if I click, I should be drawing a line. So we got a error somewhere. Let's find that. Oop. Head does not exist. So oh. I see what I did there. Had my references wrong. Number 26. Ah. Forgot property. So there we go. We're casting a ray and we're hitting an object, and it should be printing its name. Yeah, I detected Q.002. So there's a basic ray cast, right? So we could do a lot of stuff from here. So like say you want to make a gun. We can add health. We'll set it to like 100. And turn on debug so you could see it. And then if health in ray 0, does it bleed? Ray 0 health minus equals own damage. So now I can grab this and add a property to it called damage, and we'll set it to 1. And we're hurting it. So we could set that to 10, and it'll go negative real quick here. So you can use properties inside of the object, the game object, to store data or all kinds of stuff. You can build lists and then store those as properties. And then later you can pickle those properties to files and all kinds of good stuff. So next we'll do apply a force. Oh. So it'll lift up now because I'm applying a force that's 10 units on the z-axis. So it's like an anti-gravity gun. So we can also apply a force that's in line with the way that the head's facing by using own head dot world orientation times own impact. And we'll do impact as a property. Set it to like 5. Oh. Oh, I put it in the wrong object. I see. There we go. So now I'm pushing it. And then I could set this to negative and that would pull it in. And this is a little bit stronger than gravity. Oh. And we'll just go ahead and check compound on this. So it just falls because gravity is still pretty strong. So this is how you can cancel out gravity. 9.8 times Re 0 dot mass. So that makes it so gravity is non-existent. Which is kind of fun and everything. So next, we'll scrap the whole weapon and beam thing, and we'll get a localized hit point. So here's where we're hitting, right? So we can take the local and build it from Re 1 minus Re 0 dot world position. So we're taking the hit point vector and subtracting it from the object vector. And then Re 0 dot world orientation dot inverted times local. And then we're going to make a readout so we can see what's happening. And set it to a string. Own read equals str local. So there we go. There's the localized hit point according to where you're hitting the target. So say you want to shoot something in the head, or the chest, or the arm. These vectors give you an idea of where you're hitting, Or say there's a jack in the middle and you want to stick something to it. Or say you want to find what the closest axis is to this point to have that align with something else. Like I can click this and pick it, and click something else and have it fly over and stick to it. So the localized hit point gives you that information. Whatever axis is the greatest would be the one that it's on. So right now, the negative y-axis, you can tell it's on that because it says -1 up there on the vector. So I could pick this axis and then pick a hit point and have it fly to it. So we'll do that real quick. I'm going to let in my dog. I'll be right back. Okay, so first we'll do the logic for storing a target object. So we're adding the property target and setting it as a string that's empty. And then we'll do if own target, if type own target is string, which is str. So this means that it's empty. So now it should still work. So we'll do own target ray 0. So now it'll store the target as ray 0 and it won't work anymore because it's already done that part. So next we're going to add a timer so that things don't happen too fast here. We'll do time. And I'm going to go ahead and link up not equal to 0. So now this script will run if this property is not equal to 0. So we do own time equals 30. And we're going to encase this stuff in if lmouse dot positive and not property positive. We're going to change that to time actually. And then if I highlight all this stuff and hit tab, boom, it's over one step. So now I have to name this time. And then if time is greater than or equal to 1, own time minus equals 1. So let's read that out on the debug and see what happens. Oh, yeah, I have to add the sensor. So we're still throwing an error. Ah, I'm silly. So let's put this all the way down here at the bottom. No, actually I should have it above that, like here. Oh. There we go. There we go. So you'll notice the timer value resets back to 0. Okay. So we're going to go down here. So now this means we've picked the target. If type on target is string. So if it's a game object, this isn't going to happen again. It's not going to cast that ray again. So down here is the next state. So we're going to build another ray cast. So I'm just going to copy this. And we're going to look for, whatever. We don't need to look for anything. So I'm going to subtract the hit point from the target position. And this gives me the vector from here to there, or from wherever to wherever. So I'm going to put a bracket around that. And then do times, let's say 20. And then I'm going to cancel out gravity. Oops. Ta-da. So I can pick this object. Oops. Pick this object and tell it to go to that object. Or to this one. Back to that one. So rays are really fun. Alright, so next. Since we can localize the hit point, what we're going to do is storage. We're going to store a list that is the axis and the local value inside of a list. Inside of a list. So we want the absolute value of the axis. So now I have this list that I can then run sorted on and figure out which axis has the highest length. So I'm just going to grab that code real quick from here. so sorted. It appears I just lost a bunch of code. Oh no, it's right there. Never mind. So we have this sorted, and we want to take the original list, and it's going to sort it by the second value on the list, because if this was 0, it would sort it by the first value. But since it's 1, that means that's this. So this is value 0 in the first list. This is value 1 in the first list. So it sorts them by which axis is the longest. So axis equals store 0, 0. So that's the axis that's closest to pointing at the hit point. So if I hit this face, then that means it'll pick the y-axis. So if I hit this face, it'll pick the x-axis. And then vec, the vector is this, and then I'm going to use it in 2 places. So we're going to align the axis we stored to the target over time. Ah. So now, not only does it fly to the target, it attempts to point the axis at it that, let's see if it's thrown an error, if it's working or not. Okay, so we'll just turn that value right here. We'll do world angular velocity times equals 0.1. Oop, I messed up there. Now it's orbiting. All right, so we can turn this up to like 200 and do and it's much more controllable, but let's turn the amount of forces we're applying here down a little bit. So now it'll just go wherever you point it. So it's almost like an AI. It faces an axis and goes to a point. But you can see that the ray that I'm using also detects the object. So if he intersects the beam, he'll like chase himself. It's kind of cool too. Okay, so I think that's all we're going to do for tonight, but that covers a bunch of stuff.